Sir, now we are going to present the final presentation. So, a project, our group team members are Bhargava Yuchini, Sai Krishna Katamini, Srikant Chamdeli, myself Sai Krishna Katamini, and our title is Sentiment Analysis Classifier with Logistic Regression and DFIDF vector itself. So, coming to abstract. Sentiment analysis is used for determining the emotional expression which was in the written format. Yeah. So it will find the emotional expression that which was in the written format like sentences or the words. In this project, this sentiment analysis classifier is developed by two different things which are logistic regression and TF-IDF factorizer. Logistic regression is used for classification and predictive analytics, and it estimates the probability of an event occurring. And the TF-IDF vectorizer. So TF-IDF means a term frequency, inverse document frequency. This TF-IDF vectorizer is used to convert the raw data documents into matrix form. For the project, we have to train some data. For that purpose, we should need some sample data set. So for that purpose, I took um, the sentiment 140 data set as a sample data set, and the classification performance is evaluated by using various metrics. Metrics means it involved in calculating an error score to summarize the predictive skill of model. This presentation will detail the sentiment analysis and the experiment outcomes. This presentation will discuss about further uses and limitations also. Coming to introduction, the project in this project, the sentiment analysis, as I already said in the previous slide, is used to define the emotional expression behind the sentence, which is used to classify the text into three categories, which are positive, negative, and neutral. Sentiment analysis is also known as opinion mining. It is used to divide the opinions into different categories. As I already said, we use a sample data set to train the data and test the data. For that purpose, we use the sentiment 140 data set, which is available in Kaggle. Yeah, Kaggle is also, you already everyone know that it is an open source which we can select the different type of data sets for the sample purpose and for the project purposes. The particular data set consists of 1.6 million labeled tweets, which includes the all categories like which are the positive, negative, and the neutral also. Mm. So using the above attributes, the data will be trained accordingly. In sentiment analysis model, the data will be trained by using two methods. One is natural language processing and method, and the other one is the machine learning algorithms. The new text data will be trained using this model, and it will categorize into accordingly. This project will states the emotional state and the particular point of view on particular subject through sentiment analysis. So next we have to do the so yeah, here you can see that it is a IPVNP file part. So here you can see that we downloaded the data set from the Kaggle. So next one is the um, next one is the data preparation. So before starting any model training, we have to prepare data set for the particular model. We have to clean some unwanted stuff. So pre-processing and cleaning operations are performed on a data set before the data set is processed into a model. So regular expressions, URLs, special characters, these type of stuff will be removed from the dataset. So why we have to remove the unwanted stuff? So it will be done by the some performing by pre-processing and cleaning operations. So the text in the dataset will be converted into the lowercase to avoid the case sensitive problems. So Stop words are removed by analytical library. Stop words mean such as commonly occurring words without significant sentiment information. So these words are not helpful for us in the dataset. So we will remove by analytical library. By removing of these words, model will focus on essential information which make sentiment analysis accuracy. So yeah, and this is the data set preparation, the training part and the testing part. And this is here you can see that we avoided the uh, so like it's removing the punctuations and numbers and the special signs and all unwanted stuff from the data set. Yeah, so the next one is the model training. After preparing the data, then the train will be started. The training will be started. Logistic regression is used in sentiment analysis classifier to classify it into the positive and negative sentiment in binary outcomes. The sentiment 140 is divided into train and validation sets using on an 80-20 ratio. The validation set is used for hyperparameters fine tuning and avoiding overfitting. Overfitting. So the validation, where the two regression strategies are implemented to prevent overfitting. And one more thing I want to say that hyperparameters fine tuning is for finding a set of optimal hyperparameters values for a learning algorithms. These two regularizations are L2 regularization with a penalty term of to reduce model complexity, and another one is the cross validation to evaluate performance across multiple splits of the dataset. And the training model's performance is accessed on a test of unseen data to evaluate its generalization ability and effectiveness in predicting sentiment for new text input. Here you can see that how the data training is performed.
I'm going to explain about the model evaluation and the results in the upcoming next slides. We have used two evaluation metrics, the classification report and the confusion metrics, to assess the performance of the sentiment analysis algorithm. The classification report provides detailed information about the precision, recall, and F1 score for both positive and negative sentiment classifications. Precision measures the percentage of true positives among the predicted positive cases, whereas recall, also known as true positive rate, measures the percentage of true positives among the actual positive cases. The F1 score is a balanced evaluation metric that takes into account of both precision and recall, providing a single value that represents the average of two measures. The confusion matrix is a tabular representation that displays the number of true positives, false positives, true negatives, and false negatives. True positives are the number of instances correctly classified as positive sentiment, while the true negatives are the instances correctly classified as negative sentiment. False positives are the instances incorrectly classified as positive sentiment, and false negatives are the instances incorrectly classified as the negative sentiment. The evaluation was performed on both the testing and validation sets. The testing set is a set of unseen data that was not used during model training or hyperparameter fine-tuning. The validation set, on the other hand, was used for hyperparameter fine-tuning and to assess the model's performance during training to avoid fitting, which was explained by my friend in the previous slides. The accuracy of the model was reported at 81% on the testing set and 77% of the validation set. Accuracy also measures the overall correctness of the model's predictions, representing the percentage of correctly classified instances among all the scenarios. The reported accuracy indicates that model achieved a high level of success in predicting the sentiment of text data. In addition to accuracy, recall, and F1 score were used to evaluate the model's performance. Recall mainly focuses on the model's ability to identify positive sentiment correctly among all the positive cases. A high recall indicates that the model is effective in capturing all the positive sentiment scenarios. The F1 score also provides a balanced evaluation between the precision and recall, ensuring the model performs well on both positive and negative sentiments. Results after performing the sentiment analysis algorithm were the model achieved an accuracy of 76% for class 0, which is negative sentiment, and 78% for class 1, which is positive sentiment. The percentages represent the correctness of the model's predictions for each sentiment class. The recall for class 0, that is negative sentiment, was 0.79, indicating that the model correctly identified 79% of the tweets with negative sentiments. The recall for class 1, which is positive sentiment, was 0.75, indicating that the model successfully identified 75% of the tweets with positive sentiment. The F1 score, which provides an average between precision and recall, was 0.77 for both the classes. The overall performance of the model on the validation set was 77% accuracy, correctly identifying the sentiment of 77% of the tweets. The evaluation results are essential for understanding how the model performs on unseen data, as the validation set was used for hyperparameter tuning and overfitting. The results on the testing set were the model's performance compared to the validation set are the precision, recall, and F1 score of both all the classes were 0.82, indicating that the model achieved higher precision and recall on the testing set. The model achieved an accuracy of 81% on the testing set, correctly identifying the sentiment of 81% of the tweets. This model also shows the ability to generalize the new untested data and is indicated by its performance on the testing set. It is important to note that further research and testing must also be necessary to validate the model's actual effectiveness. Different data can have varying characteristics and model's performance may vary accordingly. In this slide, these are the results which were performed on the validation set. It also shows the F1 score, recall score, precision score. In this slide, the results of the actual percentages of the precision, recall, and F1 score on the testing set are provided. As you can see, it shows 81 percentage for all the classes. The final output after performing all the sentiment analysis algorithm, we can see the output which we got the negative sentiment stating that I hate the product, which implies that it is a negative sentiment.
Professor, my name is Srikant Chamaleli. As my teammate said, there are some of the limitations in this model. In that, I'm going to explain some of them. Sometimes some people will do sarcasm, comments, or other format language. It will be challenging to interpret whether the given comment is positive, negative, or neutral accurately. It will be challenging for the model because of misspelled words, slang, and non-conditional English language. This may decrease the model performance. It will be challenging for the model to interpret new words which are not present in the training data. So we have to retrain the data set regularly to maintain its securely and effectiveness. Adapt the model to changing linguistic trends and incorporating additional data sources or domain-specific data sets may improve the model's ability. Usage. JobLib library. JobLib is a Python library for running computationally intensive tasks in parallel. JobLib. Develop and JobLib. Loaded used to work efficiently on arbitrary Python objects containing large data, in particular large NumPy arrays. By using the above models and TFI IDF vectorizer, the data will be pre-processing. And there is a predict method which is used to predict this sentiment of the input sentence. Now I am going to summarize the presentation with conclusion. In this code, the sentiment analysis is developed using logistic regression and TF-IDF vectorization. In this particular code, the used sample data set is trained and tested to classify text as positive, negative, or neutral. This project gives that model accuracy and effectiveness. This statement analysis is used in various applications like customer feedback analysis. Nowadays, this customer feedback is very important for business growth. Another one is social media sentiment, monitoring and negative comment detection. As we all can see nowadays, everyone is using social media. Sometimes people will keep bad comments which affects the sensitive people. By using this classifier, the application itself delete the negative comment section. Accurate sentiment analysis is one of the assets for business to make decision making and improving products or services. Thank you, Professor.